So welcome to this Wise Owl tutorial on writing functions in Python. It's part one of two. The second part will look at advanced features of functions. So here's what you'll learn during this tutorial. We'll begin by looking at designing functions, how to work out what goes into them, how to work out what comes out of them, and the actual syntax of Python functions. We'll then look at how you can write them using the example of presenting the runtime of a film in a nice, easy to read way. And then we'll look at how you can check data types to make sure that the thing you pass into a function is the right sort of data, and to reduce the chance of runtime errors. We'll then do two case studies or two examples, one on reading in a text file, and the second one of turning a release date of a film into its age or how long ago it was since it was made. We'll then look at how you can store functions in separate modules to create libraries of useful code, before bringing everything together with a full worked example using something called modular programming or modular code. I'll explain what that is and why it's such a good thing to aspire to. And finally, in this tutorial, we'll look at doc strings, a way to document functions so you can see what arguments you pass to them, etc. At any time, you'll be able to click on the link at the top right of the screen to download any files to do with this tutorial and also to do any exercises. But at about this time of the tutorial, I normally vanish, and this time's no exception. So what I'm going to do is hand you over to my capable assistant Sven, who'll guide you through the rest of this tutorial. So let's get started. So the example function I want to start with will take the duration of a film in minutes and spit it out in hours and minutes as text. So for example, No Time to Die lasted 163 minutes, a very long 163 minutes in my opinion. If I run this program, you can see that it tells me it actually lasted 2 hours and 43 minutes. So to get this to work, I'm going to get you to create, or we're going to create together, a function called getDuration, which will turn an integer into a string of text. So let's see how you might design this function. Let's look at the function we're going to write. For example, it will take No Time to Die, 163 minutes, and it will spit that out as 2 hours 43 minutes. And it will make adjustments for films which last, for example, 2 hours and 1 minute. So it will make that singular. And for films like Dances with Wolves, which last an exact number of hours, it won't express the minutes at all. But all that's to come later. So here's how you might design a function like this. You can think of it as like a sausage machine or like a mincer. I remember we used to have one of these in my family house when I was young, a long time ago. You put in one or more inputs. So for example, for our example, we'll input the time in minutes. And whenever you have an input, you need to consider two things about it: what you're going to call it and what data type it has. So I'm going to call my argument minutes. It seems quite a sensible name. And it's going to contain an integer or an int. If you think about it, the number of minutes is a whole number. Now you could have more arguments, you could have more bits of information going into your mincer, but our example doesn't, so we'll go straight to the outputs now. Coming out of our mincer is this. It's a time expressed in hours and minutes. And again, you can do two things. You can give the function a name, so we'll call ours getDuration, and you can think what sort of information is coming out of it. So in our case, it's a string of text. And that's how you can design any function. So let's look at our specific one. So the first thing to do when you're designing a function is to include the word def, and def means define. What follows then is the name of the function, which in our case will be getDuration, and then in brackets a list of all the arguments the function needs in order to work. In our case, it'll be 1, the minutes. And finally, you say what it returns, in our case, a string of text. Indented within the function then will be all the statements it needs. These can be either 1 or 2 lines or sometimes a couple of hundreds, but at the end of it you have to return something. So that's a general definition of the syntax of a function. For our specific one it will look like this. So we'll define the function called getDuration. We'll define the argument to be passed into it as a minutes, and we'll say what it returns, a string of text. The code to actually turn an integer number of minutes into a readable string of text will follow later. But I think that's enough theory. Let's actually write the function. So to create my first function, I've created a file called getDurationFunction.py, and within this I'm going to define a function. So I'll call it getDuration, And then in brackets, I can specify or list out the arguments I'm going to pass to it. There's only one, which I'm going to call minutes. And for the moment, I won't put a data type. We'll come back to that in a second. I can then put the data type this will return. And to do that, I put a dash followed by a greater than sign. And then I can put any valid data type in Python. And finally put a colon. And then follow the lines of my function. I haven't specified the data type in minutes. And what I want to do is show you why you might want to do that. If I now type minutes dot, there's no IntelliSense or auto-completion appears, and that's because Python has absolutely no idea what I'm going to pass to this function. So I can help myself by putting :int. And what that will do is assign a data type to it. As we'll see in a bit, it doesn't actually force you to pass an integer, but it does at least prompt you to think about it. And now if I type minutes dot, it comes up with functions or methods to do with an integer, so that's a big help. So what I can now do is write the rest of my function. Now my intention of this isn't to show you detailed coding. So I'm actually I'm going to paste in my code at this point. And you of course can get the file from the list of files attached to this tutorial. Click at the link at the top right of the screen and you can copy in this text too. I've also added 3 lines at the end to test it out. So let's just briefly see if it works and then I'll explain what it's doing. So if I run that program, you can see it's working, which is good news. And as to what it's doing, it's taking the number of minutes, let's assume it's no time to die at 163 minutes, and taking the remainder of that when divided by 60. So that will give me 43 minutes there in the mins variable. It then takes the original 163, subtracts from that the 43 remainder to give me 120, and divides that by 60 to give me 2 hours of the film. Then it has a message called hour text, which basically says if the hours is greater than or equal to 2, then it will put a plural in, otherwise it will put a singular. I don't think we've seen this construct before. It's a compact way of saying if one thing is true, do this, otherwise do another, sometimes called a ternary operator. It then does the same thing to get the minutes in text, but for the minutes there are 3 possibilities. Either there's an exact number of hours, there's 1 minute more than the exact number of hours, or any other possibility. And so it just gets a text string to show the number of minutes, and finally it joins all that up together and returns it. And when you come to run it, it tests it out with 3 different films with durations of 163, 121 and 180 minutes, and gives me this output. So that's my function. What I want to do now is to look at this word int and to see what it means. Probably not what you think. What it helps you to do is to use IntelliSense within your function. We've seen that already. So you can type a dot in and it will only come up with things to do with integers. It also acts as a reminder to you that when you're using minutes within this function, you can assume that it holds an integer amount. But what it doesn't do is restrict you to passing an integer. So it's quite possible for me to go back to one of my functions, let's choose this one at the bottom, and pass in a string of text. So I'm going to pass 163 as a text, not an integer. And it will crash my function. Because the first thing we'll try to do is divide it by 60, or give the remainder when divided by 60, and that's not possible for a string of text. So when I run it, it crashes on line 5 of my function. To get around this, there's no way within a function of saying you have to pass in the correct type. And this is where Python's limitations of not being a strongly typed language for me become most apparent. It has advantages, but it does have disadvantages too. So the only way I can think of around this problem is to add extra validation to the top of every function to check whether you've got the correct data type being passed in. So in this case, I'm going to say if, and I'm going to use a new function which I don't think we've seen before called isInstance. And what that will do is check the type of something is correct. So the argument I'm checking is the minutes argument, and I'm checking if it's an int. Except I actually want to do the opposite. I want to say if it's not an int. So I'm going to put the word not in front of that. And if it's not an integer, then there's no point carrying on. I've got a problem, and I'll return no such number. And I'll put it in capitals just to make it really stand out. So now if I run that program, you can see it says no such number instead. How you deal with a return value, an error returned from your function is up to you. This isn't a very elegant solution, but at least it shows me I've got a problem. So I think there's 2 solutions to this problem. One is to solve it by adding additional error trapping at the top of every function that you create to make sure that you're passing in information of the correct data type. And the second way of solving it is just not to worry about it, and just make sure that when you call your function, you pass in information of the correct data type. Which solution will suit you depends on how big a company you work for, how large the system is, and whether you're working a team project. For most things at Wise Owl, I have to be honest and say I wouldn't bother with this extra validation. I would just make sure I pass in information of the correct type all the time. But the choice is yours. So for the first case study on writing a function, what we're going to do is read down a text file and read in the lines of films. You've got attached to this tutorial 5 files, each a CSV. So if I choose one at random, like animation.csv, and open it, you can see that it contains a list of various animation films, and the other 4 files are similar with different categories or different genres. So what we're going to do is read in these lines of text into a list. So to do that, we need to go back to our mincer analogy, my mincer analogy. The arguments being passed into this, in this case, are twofold. Firstly, we'll pass in the file path. And we'll do that to make this generic so we can use it for any CSV files in any folder. And that we will call file path, and we'll make a string argument. The second thing we'll pass in is the file name, which we'll call file name, and will also be a string of text. And then coming out of the mincer will be a single bit of information, which is a list of all the lines in the file. We'll call the function film_lines, and the thing being passed out of it will be of data type list. So now let's write the function. So to do this, I've created a file called readcsvfile.py, and what I'm going to do is create my new function. So I will call it file lines. Did I call it film lines? I can't remember now. And then in brackets, I'll specify the 2 bits of information I'm going to pass to it, which are the file path, which is going to be a string, and the file name, which is also going to be a string. And then coming out of this will be a list. So functions really can return any type of data you like at all. So what I now want to do within my file is I need to open the file. And to do this is going to be just the same as it would be outside a function. So I can say with open, I'll put my file path and then concatenate that together with my file name. I need to be careful about where the backslashes are, but I'll come to that in a bit. And I'll call that films file. So having opened the file, what I now want to do is read down the lines of text. So I can do that by get all the lines. So to do that, I will create a variable, which I'll call lines. I'll take my films file. I'll read in it in its entirety. I'll split the lines up, and then I'll pick out everything from the first line onwards. So I've done this before. It's just a way of avoiding getting the CSV titles in every single output from this function. And that's all I need to do. So at the end of my function, I can just return the set of lines I've just created. I actually didn't need my variable. I could have just put the word return there and simplified it. So having done that, let's now see if this works. So I'm going to test my function. So to do this, I need to call my function. So I'm going to say for line in, and rather than putting a list here, I'm going to put a function which returns a list. So the 2 bits of information it will return are firstly the file path. I've got this somewhere in my clipboard down here, although not necessarily. I think it's there. Then the second thing is going to be my file name. And my file name is going to be, let's go for animations.csv, since that's the one I was just looking at. You'll notice I've ended my file path with a backslash to make sure that when I concatenate the file path and the file name together, I still get a valid file name. So for each line in that list of files, what I now need to do is just print out the line, I guess, to prove it works. So what I'll do is just print that line out. Very simple. So let's now try running this. If I press Alt Control N to run it, you can see I get the lines of the animation file. And the beauty of this is, of course, if I change animation to something else, let's go for musicals instead, and run that, I get the musicals instead, except I think they were actually spelled musical. They were. So now I've got a function which will read in any CSV file and spit out all but the first line. So for my second case study for a function, what we're going to do is work out how old each film is. So we're looking at The Secret Life of Pets, which apparently was released on the 8th of July 2016, which would make it, at the time of broadcasting or the time of making this video, 5 years old. So what I want to do is take that string of text and turn it into a number. So let's have a look at our mincer. So the mincer will take in one argument, which will be the date as an 8-character string in that format. So we'll call that argument refDate, and it'll be of data type string. The function will spit out at the other end one bit of information, as all functions do, which will be the years since this date as a whole number. We'll call the function get_age, and it will return an integer. So let's now write this function. I've created a file called getFilmAge.py, and within this, the first thing I'm going to do is, from the datetime module, I'm going to import the datetime function, because I'll be working with dates. I'll then create my function, so I'll spell def to define a function. I'll call it get_age as promised, and it will take in the reference date, except this will actually be as a string, and it'll be up to my function to make sure it's a date. And what it will do is return an integer, the number of years specifically. So to do this, I'm going to create a variable to hold the date. That's a date. So I'll call this date. And what I'll do is take the datetime module's strp time function, which never seems to me to have a particularly good name. And what this will do is take a string of text, in this case the reference date I passed in, and parse it. I make sense of it, that's P-A-R-S-E, parse. And in this case, the code I need to use is %d space %m space %big Y, except they're not spaces, they're forward slashes. The little characters mean 2 characters for the day, 2 characters for the month, and 4 characters for the year. So that should give me a date, I hope. And all I now need to do is find the number of days between that date and today's date. So I'll put get age in years. So to do this, I can return the difference between today, which is datetime.today. Oops. I'll take the years for that. So that'll be at the time of speaking, 2021. And from that, I'll subtract my reference date, or this date's year. And that should give me a whole number, subject to the usual qualification that if I pass in rubbish in the reference date, it can't possibly work. So I need to make sure when I'm calling my function, I pass in something sensible. So now let's test that out. So let's just print out the age of any date I like. So let's choose the 9th of the 8th, 2012, completely at random. And if I run this, you can see it says that's 9 years old, which seems about right to me. So looking at the function we wrote called get_age, what I want to do is make this more useful and more generic by storing it not within the same module as where it's being consumed, but in a separate module. So to do that, what I'm going to do is copy it, and I think I probably need to copy the datetime module import too. Copy that to the clipboard, and I've created a separate file called wal_functions.py. It makes life easier if your module names you're going to import don't include spaces. So I'll paste that in there, and then I'll do the same thing with the other functions I wrote. So I wrote one called film lines, and I'll copy that in. Sure that I get my indentation correct. And I also wrote one called getDuration function, a slightly longer one, that one, and I'll copy that in. Now I've got a separate module holding the 3 functions, and what I can do is import references to that module when I want to use any of these functions. So let's do that. So what I'll do is I'll just save that file and I'll close down all the other 2. So what I'll then do is reference this or use this module in a new file I've created called completeexample.py. It's not quite yet a complete example, but it will be. So I've just got in my clipboard there what I want to do. I was printing out the results of calling the function getAge with a particular date passed to it. And not surprisingly, that gives me an error because getAge no longer exists. So what I need to do is I need to make sure that I've imported that module above. And you can do this the same way as with any other Python module. So the only difference here is that you wrote the code. So you can say import and then the name of the module, which was called wol_functions. And you could, if you like, give it an alias. I'm going to call it wol. Wol is our pet name for Wise Owl Training, by the way. Originally came from a misunderstanding of Winnie the Pooh. Now you can see it's underlined that, but I'm not convinced it's a problem. If I now go back to my function, I need to precede the name of the function with the name of the module it's coming from. And when I put that in and try running this, you'll see it's actually working perfectly. It's given me the age. So why is it underlined the word wol_functions in red? I don't know the answer to that question, but I do know how to resolve it. What you can do is put a comment after this saying #type:\ignore. It's something to do with the Pylance linter, the thing which checks your code for errors. And that removes that irritating warning message. And again, if I run it, you can see it works perfectly. So what we're now going to do is bring everything together to write a single program, which will loop over all the CSV files, loop over the lines within them, and print out information on each film. So I'm just going to comment out that line of code by pressing Control/. And then we'll import the glob module because I want to loop over files. This is an extra to my code. And then I can say for file in glob.glob, wonderful names these modules and functions have. And then I can paste in the path I've got in my clipboard. And what that will do if I add star.csv in there is automatically go through all the files. And check this is working. I'm just going to print out the name of the file and you can see it's listing them out there. What I now need to do is split that into the path and the file name because irritatingly that's what my function expects. So I've actually made life a bit harder for myself. So let's write a comment to this effect. Split. So to do this, I will create 3 variables. The first one I'll call file path. The second one I don't care about, I'll call an underscore. And the third one I will call file name. And I'll set that to take the file and use the rpartition function to split it by the final / character. So what that will do is divide each file name. The file path will contain everything up to the /, the underscore will contain the / itself, which I'm not interested in, and the file name will contain the actual file name, something.csv. So now what I can do is I can call my function to read in that file. If you remember, the function returned a list of lines. So I'm going to create a variable called lines, and I'm going to call my function, which is in the wol module, and was called, well, if I can't remember what it was called, I can go back to wol functions, and it was called film lines. So I can copy that in. It expects to be pathed 2 bits of information, a file path and a file name. And there's just one other complication. I need to make sure that I just have a trailing / at the end of my file path, which is why I've added that in, because otherwise I think it would fail. So that should now give me a list of lines. What I can now do is loop over these lines. Say for line in lines. And I'm now looking hopefully at a list of all the films. At this point I could do with just reminding myself of what the bits of information are. So let's quickly go and have a look. If I go to any one of these files and have a look, I'll right click and choose to open it in Notepad. And you can see that the headings are ID, title, release date, runtime, and genre. So I'll just copy that in and paste it as a reminder at the top of my comments. So what I can now do is take this line and unpack it. The line consists of a list of 5 different things. So I'll create 5 variables, which I might as well call exactly or pretty much exactly the same thing as the headings. I'll set that to take the line and split it using a comma. And so that will unpack it. The line.split will create a list with 5 items in it, and they'll be stored in these 5 variables. So then what I can do is extract all the nice information from using my functions. So let's start with get a nice runtime. So to do this, I'll create a variable called nice_time. Why not? And just to remind myself what my functions are called, it's called get duration and takes in a minute as an integer. So I can call wall dot. I have to precede it with the name of the module so that Python will be able to find it. And then in brackets, I can specify the runtime, but I need to be slightly careful. Do you remember it said it expected an integer? Well, at the moment, this is holding a string of text read in from a CSV file. So I need to do something slightly dangerous and assume it's an integer and convert it to 1. The age of the film. Using a similar process, I'll create a variable called age. The function I'm calling is called get_age and expects to be passed a string date. So I can paste that in, and then I can give it exactly what it was expecting, which is the release date as a string. And I've missed out the wall dot, which is why it underlined that. And I think that's all the information I wanted now, so I can print this out. I was going to do some nice formatting, but I think we'll just go for a simple print. So I can print out the title of the film, the nice runtime I've created, the age of it, and I'll show the genre too, just to prove they're coming from different files. Right, let's see if this works. If I press Alt-Control-N, and you can see it gives me, firstly, the action films, then the animation films, then the comedy films, and so on. So it's worked. Now, what I really want to stress about this is how much better this code is to read than had I included everything without using functions. It's called modular programming or modular code. Within this, I've called 3 functions. I've called the film lines function, I've called the get duration function, I've called the get age function. By taking a lot of the complicated code and putting it into separate functions, it has many benefits. It makes this code easier to read. It makes it easier to then reuse each of these functions in different places. And it makes each of these functions easier to test because they're much simpler. As a general guide, when you're writing Python programs, if you find that your program takes longer than a screen or 2 of text like this, you should probably be breaking it down into separate functions. Now, that's not a hard and fast rule, but it's probably a good guideline. And really, the point at which you should break something down into different functions comes from experience, I'm afraid. There's no real other way to learn it. One final thing to finish this section on functions is the subject of doc strings or document strings. These are something which most Python programmers are extremely enthusiastic about. I must admit I don't share their enthusiasm, but judge for yourself because I could well be wrong about this. Let's get back to our wall functions module. The problem is this isn't documented in any way. So what I'm going to do is add documentation to each of my functions. I can do that by creating a document string, and you do that by typing 3 double quotation marks, one after the other. And you'll find it, Visual Studio Code automatically adds in 3 double quotation marks at the end. Now, as to what I type in between these beginning and end comment characters, that's up to you. So you could be minimal. So let's just type in for this one, returns the age of something. So that's minimalistic. For the film lines one, let's be a bit more ambitious. So you might choose to type in with this is a list of all your arguments. And you might have a company convention that you type in your arguments in a certain way, or you might go on the internet and find that people have created document string conventions for you, and you could just follow those conventions. So my first argument is the file path, so where to find the file. And my second argument is the file name, and that's what the file is called. Be my second document string, and for my third one, for get duration, we'd go into more detail about the purpose of this. So it takes in a runtime in minutes. So how would you use these? Well, one way is by printing out the document string. So I've created a file called docstrings.py and just imported my module at the top and just check it's working. So if I run that, you can see it's printing out the age. What I can also do is print out document strings for each of my functions. So let's do them in the order in which I wrote them. So the top one was called get_age. So I can type in wol.getAge. Then I can type in dot and then type double underscore doc double underscore. And that's a reserved word, which means show me the document string for this. Before I run that, I need to make sure I've actually saved this file. So I'll just go and save that. And then if I try running this, you'll see it gives me the document string for that one, returns the age of something. And then if I do that for the other two functions, film lines, print the document string for that. You should see that will give me somewhat more information on that. And again, I could do that just to complete the picture for the final function, the get duration one. Will give me document string for that one. So that's what document strings are. Why don't I like them? My reservation about all comments is whether they're kept up to date. It depends on the size of the system and the size of the team you're working in. But I know for a fact that if I typed all these comments in, listing all my arguments, then on a Friday evening when I was desperately trying to fix a problem, I would add an additional argument and I would forget to document it in my list of arguments. So I'm all for adding comments explaining what things do. I think that's a brilliant idea, particularly to help you think yourself where you're trying to go. But document strings, for a very large system with multiple people working on it, I think, yeah, fantastic for documentation. But if you're working on a small team, I question whether they're useful or not. So I leave it up to you whether you decide to use them or not. So that's the end of this tutorial on using functions. What I would encourage you to do is now to watch the next tutorial on some more advanced things you can do with functions, including using optional arguments and passing arguments by position or by number, and all sorts of other goodies as well.